Today we're looking at solving equations involving radicals. In this case we have one radical, and on the following page we have two radicals. And you'll see that what's happening here is we have more terms than just a single radical as opposed and set equal to a single term. There's an extra term floating in here, so that adds to a few extra details in our algebra. This is the sequence of steps we need. We need to isolate the radical, so get that by itself, and then we'll square both sides, and then we'll do all the algebra. We need to solve for the variable, and then we do need to check for extraneous solutions in this type of a problem. So here we have root 3x minus 2 minus x equals a negative 2. We want to move all of the terms to the other side so we can get this radical by itself. So root 3x minus 2 is now isolated, setting that equal to positive x minus 2. We're going to square both sides, but you have to be careful. Don't square each individual term. You have to square the entire side. And so you wrap it in parentheses, and that means we have to FOIL this out because we have a binomial squared. On the left-hand side, the root and the power of 2 cancel themselves out. On the right-hand side, this means you have x minus 2 times another x minus 2. That's what the power of 2 says. So as we FOIL this out, we have x times x for an x squared. We have a negative 2x on the outer terms. On the inner terms, we have another negative 2x. And on the last pair of terms, you have a positive 4. So you'll notice that we do have like terms that we can combine here. So x squared minus 4x plus 4 is what we have. And this is now the key step. We have a second degree polynomial here. So that means it's a quadratic. So let's bring all the terms to the same side so that I have a positive x squared, and then we'll get to solving that. So I'm subtracting 3x from both sides. I'm adding 2 to both sides here. So we have an x squared minus 7x plus 6. And as it's a quadratic, we've learned several ways to solve this. We can factor it, and this one is factorable, and that's what we'll do. But technically, you could also use your quadratic formula. And we've also talked about how to complete the square as all good methods. So you can really pick whichever method you want. We'll continue with the factoring here because that's the fastest. We want factors of 6, positive 6. So 2 times 3 does not work because 2 plus 3 doesn't give us the 7 that we need. We want factors of 1 and 6. So making them both negative. So we multiply to a positive 6, but when they add to that negative 7. So we have an x minus 1 equals 0 and an x minus 6 equals 0. As we separate those factors, setting them each equal to their own 0, creating these little mini equations, we have two answers. Or do we? We have to check for extraneous solutions to see if any of these fail the test. So let's check this first one. Let's check x equals 1. And to do that, we're going to take that value and plug it back in and see if we have a true statement or not. So we want to know, will the square root of 3 times 1 minus 2, and then subtracting another input of 1, will that equal a negative 2? That's what we're trying to figure out. So 3 times 1 is 3, minus 2, we have a square root of 1, minus 1. We want to know, will that equal the negative 2? Square root of 1 is normal 1, and that turns into a 0 on the left-hand side. So clearly that does not equal a negative 2. So this is extraneous. We have to throw it out. That's not an answer. What about 6? So I'm going to now check for x equals 6. So take 6 and plug it back into the original equation. So we have the square root of 3 times the input of 6 with a minus 2 in there. And then we're subtracting the input of 6, and we want to know, will that equal the negative 2? So 3 times 6 is 18, minus 2 is 16 under the radical. That'll turn into a 4, and that does turn into a negative 2. So that's a match. That's a valid answer, so this is our one and only answer. So that's the process. We're going to isolate the radical, square both sides, meaning we have to FOIL out the binomial, and then turn it into a quadratic, and here we factored it to solve the quadratic. But you have to check the steps, or check the solutions. Here's another example. We have in example 2, we have root 2x plus 7 minus x equals 2. So once again, let's isolate the radical. So root 2x plus 7 equals a positive x plus 2. Wrap the entire side in parentheses because we now have a binomial that we have to square. So we have Here, let me just cancel that out. On the left-hand side, the square and the square root cancel out, so you have a 2x plus 7. And on the right-hand side, we have to FOIL this out. So x plus 2 times x plus 2 gives us x squared plus 4x plus 4. There's our power of 2, so bring everything to the same side. So we get x squared plus 2x minus 3 as we move those terms to the right-hand side. And now we have a quadratic. And this also factors. We want factors of 3 and 1. We want a positive 2, so positive 3 and a negative 1 will add up to that positive 2 in the middle. Separating our factors, we create these two little mini equations. We have possible answers of negative 3 and positive 1. And now we have to check for both of those. So let me start by checking x equals negative 3. So we'll take that and plug it back in. So we want to know the square root of 2 times that input of 3 plus a 7, and then subtract that input of 3. Will that equal an answer of 2? So 2 times 3 is 6. Sorry, that's a negative 3. Let me fix my signs here. So when we subtract that negative 3, that will turn into adding a positive. So 2 times a negative 3 is a negative 6 plus 7. That's going to be a 1 under the radical. So that would be a 1 plus 3, and that gives us a 4. So clearly that does not give us the answer of 2 we were looking for, so that one is extraneous. And then we want to check x equals 1. So square root of 2 times the input of 1 plus a 7 minus the input of 1. Will that equal an answer of 2? So 2 plus 7 gives me 9. That's a perfect square, and that does give me an answer of 2. So yeah, we're good. That is my one and only solution. Now with example 3, it looks strange because we don't have a radical at all. And what we have to remember is this rule that when you have the square root of a, you can turn that into an exponent of 1/2, right? So what we're talking about here is the index. In this case, it's a 2 because it's a square root. That becomes the denominator, and the power is the numerator. What we have is an exponential form, so we want to go backwards and convert it into a radical. So what I'm looking at here with a denominator of 3, that means I have a cubed root of x squared minus x minus 22, and the numerator 4 gives me a power of 4. So we still have to wrap this whole trinomial in parentheses because all of it's being raised to the power of 4, and we're setting that equal to 16. So now we're ready for our steps. First, isolate the radical, and it's already by itself. Now the way the steps are written on the page here, it says square both sides, but that's because we usually use a square root. Here we have a cubed root, so we're not squaring both sides, we're going to cube both sides. So I need my calculator for a really big value like that. That gives me 4096. The cubed and the cubed root cancel out on the left, so I am left with x squared minus x minus 22, that whole quantity to the 4th power. Now we have to get rid of the power 4, so we take the 4th root of both sides, and that leaves me x squared minus x minus 22 equals, now that is a perfect 4th. Again, I'm using my calculator here. That gives me an 8 on the calculator, but that's an even root, so you want to remember both your plus and your minus. What that means is we actually have two different quadratic equations. So we're going to split this up here. X squared minus x minus 22 equals the positive 8, and x squared minus x minus 22 equals the negative 8. So in the first case, when I'm subtracting 8 from both sides, we get x squared minus x minus 30. And in the second case, I have to add 8 to both sides. We get x squared minus x minus 14. So with two different quadratics, that means this will give us 2 answers, that will give us 2 answers. There's 4 answers, and we're checking all 4 answers. So this first one factors very nicely. Factors of negative 30 are 6 and 5. We want the negative on the 6. And as we split these up, we get possible answers of 6 and negative 5. For the second, This one does not factor. Factors of 14 would be 7 and 2, and there's no way to add or subtract 7 and 2 to give us a -1 on that middle term. So that means we have to use the quadratic formula. So x equals, so remember your A and your B and your C. So this is your A, this is your B, which is a -1, and that's your C of -14. So negative B, so the opposite of -1, plus or minus the square root of B squared, so -1 squared, minus 4 times A, which is the 1, times the value of C, which is a -14, all over 2 times A, so again 2 times 1. So that will simplify into 1 plus or minus root 57 over 2. So how in the world are we supposed to check that? So when we get to checking this, what we're going to do is we will just temporarily turn it into a decimal value, so it makes it easier to type in our calculator as we check. And I'm going to 3 decimal places just to make sure I have a bit more accuracy. So it's either 4.275 or -3.275. So those are the 2 possible answers, along with the -5 and the 6. So we have these 4. So on my check step, I'm going to start off by checking x equals 6. So we're taking that, and I'm plugging it back not into the original, but this radical version of the equation. So we have the cubed root of input of 6 squared minus a 6 minus a 22. All of that wrapped in parentheses to the power of 4. And we want to know, will that equal 16? So 6 squared is 36, minus 6 is 30, minus 22, you actually get 8. And you could go 8 to the 4th first, but I'm actually going to do the cubed root of 8 first because I recognize that's a perfect cube. So the cubed root of 8 is 2, and then when you raise that to the 4th power, that gives us 16. So yeah, that does check out. Same with checking x equals -5, cubed root of -5 squared minus a -5 input minus 22. All of that raised to the power of 4. Again, we want to know, will that equal 16? So if this squared is 25 minus a -5, that's the same as adding a +5. So that gives us 30. 30 minus 22 brings us right back to 8 again. So you can see that we'll get the same result because we're at the same point in the process here. Take the cubed root of 8. That will turn into a 2. 2 to the 4th is 16. Yeah, so that checks out as well. Now for these decimal values here, we're using our calculator really because that's just really the only way to do it. So if we were to check x equals 4.275, this is just what it would look like when we type it in our calculator. We got the cubed root of, and then inside that we have this 4.275 squared minus 4.275 minus 22, and all of that is being raised to the power of 4. We want to know, will that equal 16? So when we type this in, you end up getting something like 15.997. And because we rounded to 3 decimal places, it's fairly accurate. While it looks technically different, it is a valid answer because we're going to round up to 16. And we did that because of our decimal approximation. So to save a little bit of time, I'm not going to plug in the other one, but it turns out all 4 work. There's no extraneous solutions here, so we've got 1, 2, 3, 4 total answers. They are all valid. So that's the technique when we have exactly 1 radical. We isolate the radical, and then we square both sides, or cube both sides in this case. But what if we have 2 radicals? So that's what we're looking at on the next page. Here you can see in example number 4 that we have 2 radicals, which means it's going to be impossible to isolate both of them because we also have another term as well. So we're going to just pick one of the radicals to isolate first. It doesn't really matter which one, we'll just pick one, we'll square both sides, and then we'll still have another radical around, so we'll have to do that process all over again by isolating and squaring. And then once we solve for x, we'll check for those extraneous solutions. So we could isolate either one of these radicals in example number 4. But it's a bit more work if I choose to isolate the second one, because I'd have to move the first radical to the other side, and then we'd have to divide away the -1. it's just faster to add root x plus 5 to both sides. So we keep the root 3x plus 4 where it is. That's what we'll isolate. So we have 1 plus root x plus 5 on the right-hand side. So now we're ready to square both sides. Remember, wrap the entire side in parentheses, and that means we now have a binomial on the right-hand side. Even with that radical, it's a binomial. So we have a 3x plus 4 on the left. On the right, let's see what that would look like if we write it out. 1 plus root x plus 5 times another 1 plus root x plus 5. So let's FOIL the right-hand side. So 1 times 1, and then the outer terms gives me a positive root x plus 5. The inside terms gives me another root x plus 5. And then when we multiply last times the last, there's a shortcut here, but let me just remind you that when you are multiplying the same thing, you'll get the power of 2. So you end up with a radical x plus 5 with a power of 2 because you're multiplying the same thing to itself. So here the square and the square root will cancel out. And on the second and third time terms, those are like terms, and they will combine as well. So 3x plus 4 on the left equals 1 plus 2 of those root x plus 5s. And then on the far right-hand term, the square and the square root cancel out, leaving with just a term of x and just a term of 5. That's the result of squaring both sides. Now, we want to isolate the other radical. You can see there's still one radical here. So we need to get that by itself. So let's push all the terms to the left-hand side. I'm subtracting x from both sides. Here we have a 1 plus a 5, which is a 6. So we're technically subtracting 6 from both sides. So we end up with a 2x minus 2 equals 2 root x plus 5. What do you think? Is that radical isolated now? No, it's not. We still have this multiplier of 2. So we have to undo that with division. Let's divide both sides by 2. So 2x divided by 2 is 1x, and negative 2 divided by 2 is a negative 1. And those cancel out, of course. That leaves you with just the root x plus 5. So now it's isolated. So now we're going to square both sides. And once again, remember to wrap that in parentheses because you have to FOIL out the binomial yet again. So on the left side, that gives us an x squared minus 2x plus 1. The right side is x plus 5. So again, move all of the terms to the same side. I'm moving them to the left, so I have a positive x squared there still. X squared minus 3x minus 4 equals 0. Now we have a quadratic, so you can quadratic formula, complete the square, or factoring. Factoring does work. We want factors of 4 and 1 so that we can add or subtract them to get us that negative 3 in the middle. So I want a negative 4 and a positive 1. So we get x minus 4 equals 0 and x plus 1 equals 0. And then those are the two answers. Or are they, right? We have to check. So here's our check step. Let's check x equals 4. So going back to the original problem, there it is. The square root of 3 times that input of 4 plus 4. And then we're subtracting another radical with an input of 4 plus 5. We want to know, will that equal 1? So 3 times 4 is 12. 12 plus 4 is 16 under the first radical. 9 under the second radical. We have a 4. We have a 3. And we get a result that is 1 equals 1. So that is true. This is a valid answer of 4. Now let's check x equals negative 1. So plugging negative 1 in for my input, we have the square root of 3 times negative 1 plus a 4. Subtracting the next radical, input of negative 1 plus a 5. We want to know, will that equal an answer of 1? So 3 times negative 1 is negative 3 plus 4 gives us just a 1 under that first radical, and then we have a 4 under the second radical. So that gives us 1 minus 2, and that's going to give us a negative 1. So we can see that will not give us the answer of positive 1 that we need. So that is extraneous. So there you have example number 4. Same technique here for the next example. We'll just take you through it one more time so you can see all the details because there's obviously a lot of steps. Here's example 5. So again, we're going to pick a radical to isolate, and we'll move the other to the other side. So we have a root 2x plus 6 equals 1 plus the root x plus 4. We square both sides, and we now have a binomial squared, so we have to FOIL this out. And because this binomial has the radical in it, I do recommend that you write it out longhand like this, where you have it being multiplied against itself. It makes it easier to figure out what we're doing with the multiplication as we FOIL that out with the radical in there. So we get 1 from the first term. The outside term is a root x plus 4. The inside term is another root x plus 4. The last times the last will give you the root x plus 4 squared, because there's 2 identical copies. So these will combine, and then the root and the square will cancel out. So we have 2x plus 6 equals 1 plus 2 times the root x plus 4 plus an x plus a 4. So here's the radical. We want to get it by itself. So let's move all the terms to the left-hand side. We're subtracting x from both sides. Here we're subtracting a 1. Here we're subtracting a 4. So that's a grand total of 5 that we're subtracting from both sides. I'm subtracting 5. So we have 1x plus 1 equals a 2 root x plus 4. The radical isn't quite by itself, so we have to divide away that 2 from both sides. And now we come across a situation that looks a little bit sticky here. We have this x, but it doesn't really divide by 2, nor does the 1 divide by 2 unless we want to leave it in this form, and that's really weird. So what we're going to do instead is we're going to place this divided by 2 in front as a 1/2. It will be easier for our next step when we square both sides. So wrap everything in parentheses to square it. And what this means now is you have a 1/2 that's being multiplied by a base of x plus 1. So each base gets its own power of 2. So you have a 1/2 that has to be squared. And you have an x plus 1 that has to be FOILed out. So you have a 1/4 in front, and then x squared plus 2x plus 1. And on the right-hand side, you just have the x plus 4. Now, the reason why we kept this fraction by itself is so that we weren't distributing it to the terms, because FOILing out with a fraction would be extra challenging. But notice how simple it is to eliminate the fraction now. By keeping the fraction by itself in front, we're just going to multiply both sides by 4. And so we'll distribute the 4 on the right-hand side, and on the left-hand side, 4 over 4 cancels out. So we have x squared plus 2x plus 1 equals 4 times x, and 4 times 4 is 16. Now the fraction is gone completely. So that's the technique. Keep the fraction by itself, and then we'll just multiply both sides by that fraction to clear the denominator. Let's bring all the terms to the same side. So x squared minus 2x minus 15 will be the result. And this factors into a -5 and a +3. And final answers are 5 and -3. But again, we got to check. So I'm trying to fit my little check step here in this margin space. Let's start by checking x equals -5. We're going to take that -5 and plug it back into the original problem here. So we're taking a look at the square root of 2 times that input of -5 plus 6. And then we'll subtract the next radical, which is a radical. Here's my input of -5 plus 4. Sorry, it's a +5 there that we are checking. Yes, it is. Let's try that again. Let's plug in a +5. Okay, here we go. So 2 times 5 is 10, plus 6 is 16. And 5 and 4 is a 9. Those are perfect squares. So we have a 4, and we're subtracting a 3. That gives us a 1. And that does equal the 1 that we're looking for. So that's a valid answer, +5. What about the -3? So let's check x equals -3. So this is the one that's negative. So here's my first radical. We have 2 times the input of -3 plus the 6. Then we're subtracting the next radical, plugging in the -3 and adding 4. So that's a negative 6 plus a 6, that turns into root 0. Then we're subtracting. Here we have a negative 3 plus 4, so that's a root 1. And that does not give us the positive 1 we're looking for. So negative 3 is extraneous.